Alright guys, welcome to my 11 and a quarter minute update video for the Green Engineers. Today is like June 25th or 26th or something. I should be able to upload it today, so whatever date you see on the YouTube video is the day it is. Got the shredder back up and running. We got this new, I know it's been a month since my last update, but we are in pretty good shape. We are going forward each and every day. So we're going to go over the standard update here and all the different projects that we have. So here is the new shredder setup here. So basically we added these two washers. These are not the right bolts. These are the bolts that I had laying around. And so instead of having this one contact over this entire shaft, we have 3/4 of an inch instead of just a 1/4 inch. So now this is enough that it when it moves, it actually will be able to stall this, and I've stalled it a couple times. So let's go ahead and talk about this. So this is like one of the examples for a higher feed. I decided that I'm going to put the big gear here and a small gear here to step it down. So right now it's stepping up. So this guy's about 20 RPM, 17 to 20 RPM, and here it's about 30. So it's about 30 RPM. So the difference is the circumference of the contact area of this versus this, or you could think of the teeth of this versus this. This has 1.5 times the teeth this one does. So what I'm going to do is I'm going to put a big gear here and a tiny little gear here, and hopefully get it down to about 5 RPM or something like that. That will drastically increase the torque and the things that you can shred. So with this guy, I struggled to shred a water bottle completely. It got stuck on the lid right here. So this is the water bottle here. As you can see, it bottomed out on the lid. It got stuck on the lid and it just stalled out at that point. And there's a couple of extra things. For example, I need something back here to keep these inserts in. Let me show you the inserts. So you can see here there are some inserts that turn this bearing or this shaft from a square into a circle, and then allows it to adapt to the bearing. Now on the back side, there's nothing that keeps it from falling out. So in the new design that me and Kevin have, which me and Kevin are still working on it daily, 2 hours a day at night, we need to get a design to hold in these bearings and also those I guess bushings almost in the back. So, but it runs pretty great. This motor is very dependable. It runs great, and I've been recently shredding these guys. These are some COVID-19 masks, braces on the bottom that Prusa designed. This is a newer version. Our local makerspace that me and this person were making it for, right? They were still using the older versions, not the newer versions. So he accidentally printed these, and they were not the correct version. So I told him that I was going to shred it and put it in the shredder and shred it up. And now this is what we have when we're done, which these are some other clear mask as well. And you could see how uniform these cuts are. And the funny thing is that if you take a caliper and you measure, let's say like these three, right? And so this is only fed through once. In actuality, you would feed this through multiple times to make them smaller. So this is one cut, and then you would put another cut, and theoretically the finished product would be a 1/4 inch by 1/4 inch square. And the reason being is that the gap between the blades is a 1/4 inch by 1/4 inch, right? And so that's the gap between the blades. So that should be what this is. Now, if you see caliper here, we grab a caliper and clean off the blades here, right? See, 254, 254, 256. So very, very good consistent thickness, right? And it just chews through these like butter. But if you had 2 of these in there, it will stall with this type of gearing. So I do not like how this is geared. So we definitely need to be changing the gearing to something that has a better, that has a down gear. And I really don't think it's going to be that big of a deal with the loss in feed. because at the end this will have a giant 12 by 12 by, so 12 by 12, this is 6 by 6, well 6.5 by 6.25 or something like that, and or 6.5 by 6. Anyways, so there's going to be a hopper on top that goes to 12 by 12, and so that will be, and it's 12 inches tall, so it's about this tall. Can't even see it, it's out of frame. It's up here somewhere, right? And when we go to that hopper, which is again about this tall, yeah, it's even taller than that frame. So when we go to that hopper, we have to be able to fill it in, and obviously there's going to be more stuff that goes in there that it needs to be able to shred. So that needs to happen. And also I need to make a slight adjustment where, as you can see, this is a piece of PLA sheet from my work from the cafeteria. You can see Eco Products. It's made out of the PLA from NatureWorks. And you can see that the blades are not quite close enough together to completely shear it. Now, if you put enough force here, you could actually tear it, where it's so close to being through, but not quite. Right? And it did chew through that fine and went all the way through. So this is definitely thin enough to be used with this. But if it can't shred water bottles, then there's not really a point. And as you can see, it did shred the water bottles when it put the two thicknesses together. So this current design, I think it could probably do, it could do 1/32, 32 thousandths. So it could cut 32 thousandths, no problem. Anything thinner than that, I'm unsure whether or not it will be able to shear it because of the gap between this blade and this blade. There's not enough overlap between the two blades. So if you look at it, let's say this blade is one blade and this blade is another blade. The overlap between the two is not enough. It's like this, it should be like that. So that way the plastic can't find its way in between there. Alright, so here is my test piece. Let's go ahead and put it in there and start it up and watch you guys and show you guys it getting crushed. Alright, so here we go. We got safety glasses on. Let's go ahead and start it. And you'll see that it goes around a couple times until it gets them all out, gets it all out of the blades. And we're still working on electronics, and there you go. There are the pieces. Again, very consistent. I bet you these are all quarter inch. They're all very consistent. Quarter inch, and you can see all the stress built up there with the white, how it turned into white. And this is eSun PLA. So this is the same thing this guy's printed out of. It's pretty common, you know, eSun's pretty common material, and I'm sure it's made out of NatureWorks or maybe some other material that they have in China, because I believe it's a Chinese brand. So I guess that's it for the shredder. Shredder production is doing good. We just need to do the electronics with all the interlocks on the back, do the shroud, do the stand, do some pinch guards on the front and the back, and do the correct gearing and do some more testing. And I think we're done with this project. So also we finished, we've been working on the development of the waterjet. And the waterjet is kind of reaching ahead right now, and that's one of my most popular videos, is talking about the waterjet. So I recently got back into the project. That's what me and Kevin have been focusing on mostly recently. And we bought like 80% of all the high pressure parts that are needed. And we bought all of the most of the low pressure parts that are needed for the water and the air pressure. And I made a mistake where I ordered parts off of a pump that I was originally quoted, but I didn't end up buying. I ended up upgrading the pump to a different pump, and I accidentally didn't read the spec doc, and I bought one for the one that I was originally looking at and not the one I actually bought. So that guy is coming in, so I had to rebuy that stuff, and that's coming in from Amazon here pretty soon. I have the rest of the stuff ready for the water and the air pressure. So I have not received the high pressure components yet. Some of them are high pressure tubing that needs to be hand bent, and also everything else should be good to go to where I could plug in my high pressure tubing and I do not have. I need a couple custom glands and yeah, basically just a custom collars. Sorry. So we have, glands. We need a couple custom glands to adapt to the cutting head and also to the pump itself. So right now what we're going to have to do is we're going to have to, I want to run a video where I just shoot it out of the 2 orifices that come out of the high pressure side of the pump. And both those high pressure sides are, I think, 1/8 of an inch holes. So 2 1/8 of an inch holes. Now again, on my high pressure tubing, it's only I think it's only either 80 thousandths or 1/8 of an inch hole. And on my water jet, I have a 5 thousandths orifice. So, and then a 20 thousandths mixing tube. And also, generally the standard is you want 3 times the size of your orifice as a mixing tube. So I will try to get a custom 15 thousandths cut for me, 15 thousandths mixing tube. But right now I'm going to work with a 20 thousandths. So the next update you should see here pretty soon with the water jet, and that guy will be probably an exclusive talk on that guy. And then you'll see some more update on this guy, and also me and Kevin are working on, while we're waiting for parts for the water jet, we've been working on the Filafactory, which is version 2 of my extruder, my filament extruder. Alright, see you guys in the next video.